Greetings, mathematicians. In this video, we are going to be learning how to simplify rational expressions. But first, let's start with a quick warm-up, reviewing how to factor polynomials. So go ahead and pause the video and try these two problems, and then come back to check your work. All right, now that you've had a chance to try these, the problem on the left had only a GCF of 2x. Recall that you start by factoring out the GCF, and it's sort of like the inverse operation of distributing, and you look for first a numerical value, 2, 18, and 4, those are all divisible by 2. X cubed, x squared, and x, those are all divisible by x, so you bring that out in front, and then you ask yourself what happens when you divide out that value, and what's remaining is what goes inside of the parentheses. For the second question, number 2, remember that anytime you have a leading coefficient that is negative, you want to take out a GCF that is negative. And in this case, the leading coefficient is only a -1, so there's no other numerical value that we can take out. And the 36 does not have a variable part to it, so we're only taking out a -1 for the GCF. Then we're left with x squared minus 36 in the parentheses, which is a difference of squares, and factors into x plus 6, x minus 6. So moving on here, our question of the day is that we want to know how can we simplify rational expressions. Now, one thing we want to keep in mind is we want to remember what rational numbers are, because that's going to help us understand what rational expressions are. Remember that rational numbers are numbers that can be written as ratios or fractions where the numerators and denominators are both integers. So 1/2, where 1 and 2 are both integers. 4/3, where 4 and 3 are both integers. So these are examples of rational numbers. Now, a rational expression is similar. It's going to be a fraction, but this time, instead of the numerator and the denominator both being integers, this time the numerator and the denominator are polynomials. So 3 over x plus 4. The 3 is an integer, but the x plus 4 is a polynomial. The 2x and the x squared minus 9, those are polynomials. So all of those three examples that you see here, these are all polynomial expressions in the numerators and denominators, which makes the fractions themselves rational expressions. So let's look at a few examples. Our goal here is just like when we simplified fractions back in elementary school, we looked for common factors in the numerator and denominator that we could divide out because they would essentially equal 1. So for example, if this question number 1, if it was just 2 over 18, what we had done in elementary school is that we would write 2 over 18 as 2 over 2 times 9. We would write the 18 as 2 times 9 because we were trying to write it with a common factor, with the 2 in the numerator. And then we would take the 2 divided by 2, and we would replace that with 1s, and we would get 1/9. So the 2 divided by 2 equaled 1. So what we're going to do is something similar here, except for now, instead of just working with numerical values, we've added in variables as well with our polynomials. So instead of just 2 over 18, we've got 2x over 18x. And instead of just simplifying 2 over 18 to 1/9, we can also simplify the x over x. X divided by x also equals 1. And the 2 divided by 18 also equals 1/9. So just like you did with numerical values, you'll simplify those fractions like you always did, and now you'll have variable parts that you'll also be looking to simplify. Now looking at example 2, we've got the 3 over 6, which reduces to 1/2. And we have an x over an x squared. Remember that x squared means x times x. So if we're trying to simplify here, we've got one set of x's that are going to divide out to 1. X divided by x equals 1. So in the numerator, we have 1 times x squared plus 6. That's going to leave us with x squared plus 6. And in the denominator, we have 2 times 1 times x, which is going to leave us with 2x. Now, in question 3, we actually have nothing here that simplifies. Be a little careful, you can only simplify across multiplication here. So if you look at all the problems we've done so far, we've been simplifying across multiplication. In this problem, we have an addition symbol here, so you can't simplify, for example, this x and this x. You wouldn't be able to say that those divide out to a 1. So this one actually doesn't simplify at all, and it's still just 2x over x plus 2. Next up, I'd like you to try these 3 problems. Pause the video while you do that, and then come back to check your work. All right, now that you've had a chance to try those, you can check your answers here. And in the next video, we're going to look at how do you try problems like this when they're not already in factored form. See you soon.